Okay, now in the last video, I want to review how to compose functions together. Okay, this is called composite functions. Okay, plus operation, line up your parentheses, make room so you got 1, 2, 3. So f function's 3x minus 2, and the g function's 9x to the second plus 1. So 1, 2, 3. Okay, 1 I'm not going to do because I have a power, but it's just to the variable. There's nothing to distribute, so you go to your like terms. This should be pretty easy. 9. Regular x, you got 3. Negative 2 plus 1 is negative 1. Then you insert your negative 2 into the expression. Negative 29. Okay. Make your subtraction. Means you write a subtraction of two separate functions. So your g is 9x to the second power plus 1. Then your f 3x minus 2. Okay, so again, the power is just to the x. Don't worry about that. You don't have to duplicate anything. You can't duplicate an x. It's stupid. There's nothing to distribute. Then, okay, x to the second, you got not. Oh yeah, by the way, make that plus, negative, plus. Because otherwise, if you don't do that, then you're going to end up with the same thing you did here. If you end up with the same thing here as here, you're doing something wrong. They should be slightly different. So you'll have a 9. That's the same as that. But then I have negative 3 instead of positive 3. And then 1 plus 2 is 3. Okay, now insert your 3 into the composition. $75. Okay, now division's kind of a special thing. It's a lot less work. G is going to be 9x to the second. You got to put the g in the numerator. That's what they want. They want the g in the numerator, the f in the denominator. Now don't try to simplify that, okay? I have people trying to simplify it and mucking it up. Just leave it. Now put negative 2 in the expression just in the numerator to start with. Okay, so my numerator is 10. My denominator, 3 times negative 2 is negative 6. Minus 2 is going to be negative 8. You can leave it like that. You can also reduce it by 2. And also, technically, the negative is just in front of the whole fraction. I don't really care about that. Okay, now we get to the dreaded inputs. You got to know how to do that first. You're going to do 1, 2, 3, but you got some things you have to square away first. You write your g down first, which is 9x to the second power plus 1. Then you replace the x, but not the second power. The second power now transfers to the outside, plus 1. And you fill that in with your f, which we know is 3x minus 2. So now that's ready to go. Simplify. You're not solving. You don't use q. That's a solve for x. We're not solving for x. This isn't an equation. It's just an expression. So it appears to me that the 2 belongs to the whole parentheses, so we need to do step 1. Okay? 9 parentheses without a power plus 1. So I took away the power. Well, then to fill that in, I need to go duplicate this out twice and find the product. 3x times 3x. 3x times negative 2. Negative 2 times 3x. Negative 2 times negative 2. So it's 9x to the second, negative 6x, negative 6x, and positive 4. So x second, you have 9, negative 6, negative 12, and then 4. Okay, and that's what we put in there. 9x second plus negative 12x plus 4. You have to do step 2 because you got a 9 distribution. 81x to the second. 9 times negative 12 is negative 108x. Then 9 times 4 is 36. And don't forget the plus 1. So 81, negative 108, 36 plus 1 is 37. Okay. That's it. You notice out here I'm not giving you, I forgot to give you a number there. If you get a number off here like you did on those other ones, you plug it in. I forgot. Okay, now I start with the f function. And that's 3x minus 2, still the input. So now I replace the variable. There's no power, so I'm not going to have a power outside the parentheses this time, and that's good. Then I replace my x variable with the g composition, which is 9x second plus 1. Okay, now I'm ready. 1, 2, and 3. Okay, step number 1, distribute 3 to 9, 3 to 1. Okay. You don't have to do step 1 because the power is just on the x. It's not to the whole parentheses. So 27x second plus 3 minus 2. So you got 27, and 3, 2, positive 3, negative 2, add to 1. Okay. Now if I add f, if it said f input g of like 3, I'd put 3 in. I didn't give you one though. So just worry about getting those simplified. Okay, now you can put your calculator away. You're not going to need that for the rest of this. Now you're going to want to pause the video and go work on certain problems first. Now this time you're going backwards. The composition's done for you, and you have to determine what the separate functions were. Okay? So it's like going from, and you're not going to need a calculator. Okay? So it's basically like you're taking this and then getting back to these two things here. You're like, well, gee, that sounds really crappy. No, they're written in a way where it's really easy. First off, a lot of times your expression is inside of something. This time it's in a cubed root. So just circle the expression itself that's inside of whatever. Could be a cubed root, could be an absolute value, could be a parentheses, so forth. There's what you do. You write cubed root, and you replace that with just a regular x. And then your g is equal to whatever expression is circled. Done. Okay? Because if you wrote that out and replaced x, you'd replace it with x minus 6, which would take you back to the original, to the composition. Okay, now circle the expression that is confined inside of a mathematical structure. Mathematical structure means a root, an absolute value. Okay, this is absolute value. Okay, so I have 3. I have an absolute value, and then I replace x minus 4 with just x for the f function. Then the g function is the x minus 4. Okay, same thing here. The mathematical structure is a parentheses. Parentheses, power of 3. Just put x there, and then x minus 4 goes here. That easy. Literally, that's all you do. Okay, the structure is a parentheses. Okay, so 5 parentheses, second power. Everything else is the same. We just, instead of x plus 3, we just put x. Then x plus 3 is my g function. By the way, if they flip it and go g of x, then you do your g first, and the x is the part, but that's not going to happen. Okay, this got cut off. It's a square root over the whole x minus 2. So this is the within the confined expression. So you got a 3. You have a square root. If you don't see anything in the index, it's a square root. Then, but instead of x minus 2, we're just going to put x. Then x minus 2 is my g. Okay, same thing, just circle the expression. Okay, so I have a 5, and then I have a parentheses, but instead of x minus 4, I just put x, then I close my parentheses to the second power minus 4. And I put x minus 4. Okay, next one. You have a 5. You have an absolute value, but instead of x minus 2, we just put x and then plus 3. Then the g function is the x minus 2. It's like you're separating the composition. Okay, next one. So make your square root. Instead of x minus 7, we just put the x by itself, and then x minus 7 can serve as my g function. Okay, now pause the video and go do 1, 2, 3, 4. Should be pretty easy. This page here. Last page, 1, 2, 3, 4. Okay, now in our next group of problems, what you're doing is finding the inverse relation, okay? Actually, let's go do these examples first, because those give you the directions. Find the inverse function. Here's how you find an inverse function. First, it's a two-step process. First, you switch x and y, okay? You just put an x where the y is at and a y where the x is at. Now, when you get into trig, this helps you with graphing, okay? Will help you, but for now, it's just kind of mindless. In the second step, you need to isolate the y variable. The y has to be by itself, so I have to undo any operations with the y. So first we undo the minus 1, so I plus 1. Now I plus 1 to the x. No, that's not 1x. 1x is x times 1. X plus 1 just stays x plus 1. Okay, just leave that the way it is. So we now have x plus 1 equals 8y. Then we undo the multiplication of 8 by dividing by 8. And now the y is by itself. So I have x plus 1 all over 8 equals y. That's your inverse. Okay, next one. Swap the x and the y. You just put the x, just have them switch places, and now you get the y by itself. You have a plus 3 you have to undo. You undo any minus plus first. So you just leave that alone. That's x minus 3. And then negative 20y. Then I undo my multiplication by negative 20 by dividing by negative 20. And now the y is by itself. It has no more operations. So x minus 3 over negative 20 equals y. Notice how I don't have to use a calculator for this. Okay, this time you swap the x and the y. But this time it appears we have to undo the minus plus 7. So x plus 3. X plus 7, my bad, x plus 7. Now undo your multiplication just like you did on the last one by 2. But you don't have your answer yet because you have a power. So to undo a third power, you make a root, and it's a cubed root. That cancels. Now you put a root over the entire thing and put a 3 in the index, so that's a cubed root. I need to see the index exponent. Okay, so now y is by itself. We have the cubed root and then x plus 7 all over 2. That's the inverse. Okay, switch the x and the y. Undo your minus 6 first. Remember, don't write that as 6x. That stays x plus 6. Okay. Now you undo you don't have to divide because you don't have a multiplying number there. Okay, now you undo your second power by making a root. This time it's a square root. And these cancel. The second power and the square root cancel. and I have a square root. I want to see the 2 in the index so I know what kind of root it is. X plus 6 equals y. Okay. Okay, now I'm going to flip over and do more to the back side. Flop those, swap them. Okay, now minus 3, so x minus 3. Then I undo the multiplication of 7 by dividing by 7. And that gives us, I have no exponents, so now I'm ready to write my answer. We have x minus 3 over 7 equals y. X equals 8y minus 1 plus 1 plus 1. Undo your multiplication of 8 by dividing by 8. Okay, there's no power, so I have my answer. I don't need a root. I don't need a radical. Okay, then follow that up, replace the x and the y. Undo your plus 7 by minusing 7 from 7. Now you got to undo your multiplication of 4 by dividing by 4. Okay, now you do have a power, so you need to undo a third power with a cubed root. You make a root, put a 3 in the index, gone. Make a root, put a 3 in the index. Now I have the y isolated. And I have the cubed root of x minus 7 over 4. Cubed root's over the whole thing. Okay, and then last but not least, we got x. Switch them. Now you don't really have to calculate anything because it's just variables, okay? You just have to know how to write the expression out. It's not that hard. Okay, now you don't have a multiplier, so you're not going to divide, but you do have this fourth power. Fourth root. Put a root over the top of both sides, and you put a 4 in the index to cancel there, and then just a 4 in the index. So I have a cubed root, a fourth root of x minus 10 equals y. Now y is by itself. Boom. Now you can do the last 4.